So today we are going to build a home automation circuit for our home lighting. So here we can see that I have built a circuit which consists of no microcontrollers or anything digital, so except this transistor, but that can also be considered as an analog component. So here this circuit is built using analog components only, so it is fairly cheap and power efficient. So let's see how it works. So as you can see, it has a really quick response and can handle a 220 volt AC supplied load. So let's get started. So here are the components that we need. First, we need a 10K trimmed potentiometer, a LM358 op-amp IC, and it is in DIP package, so I can use it with breadboards, a 10 kilo ohm resistor, a 1 kilo ohm resistor, an NPN transistor is required. NPN transistor you can use any model, but I would prefer using BC547 transistor. A relay. Now I am using a 12 volt relay because I am using a 9 volt DC power supply. So I would also need a DC-DC step up converter. Now I have set this converter to produce a 12 volt output. Now if you have any other configuration, you might have to set it to 12 volts to get the best result. Now let's start build, and of course we will need a lot of wires and a 9 volt supply, 9 volt battery. Here I am using this transistor battery. Now let's start building it. And one thing I forgot to mention, we also need a 10 kilo ohm LDR. It is the light dependent resistance. So let's start building the circuit. First we should place all the components. I have placed the op-amp IC here, the potentiometer over here, the BJT transistor over here. And one thing to be noted, that it is not a MOSFET transistor or IGBT transistor, it is a BJT transistor, typical BJT transistor. And let's place the LDR over here. And because it is a 10 kilo ohm LDR, so we are going to build a ballast circuit with the 10 kilo ohm resistance connected with the ground in series. So let's connect the power first. Okay, I'll connect the power later. Now here is the 10 kilo ohm resistor placed, and let's place the 1 kilo ohm resistor to the base of the transistor. Here. So it is now placed at the base. Now why I am using this resistor? Because we need to limit the current to the base, otherwise the transistor can burn. And now let's place the relay over here. Now you can see that I have already placed a wire over here, and it is connected with my light bulb, so that I can provide the neutral connection from the middle pin, or the common pin of the relay. So I will connect my neutral wire with the common pin of the relay like this. Here is my neutral wire. Here is the neutral wire, and I will connect it with the relay like this, so that I can place it on my breadboard easily. It's placed now. So now I will place my relay on the breadboard. Like this. Now always keep an eye on the pins of the relay, otherwise the relay won't work. And now, as I have set the relay on the breadboard, now I am ready to make the other connections. So at first I will configure this potentiometer. So on the power pin I will connect the power and connect it with the 9 volt positive supply, and the ground to the ground like this. And now I will connect the output of this potentiometer to the non-inverting point of my op-amp IC. Now why I have used this potentiometer? Now by adjusting the potentiometer I can control the sensitivity of the whole circuit. So it is now, it will be placed at the non-inverting point. And now let's take another wire and place it in here. One second, my wire just okay. Now the wire is placed, and now the output from the LDR will be placed at the inverting point of my op-amp IC. Now let's connect the VCC and the ground for the op-amp. The pin number 8 is the VCC of the op-amp, and I will connect it to the positive of my power supply, and pin number 4 is the ground of my op-amp. So I will do the same for here. I will connect it to the ground like this. And now the output of my op-amp, which is the first pin, will go to the resistor connected to the base of the BJT over here like this. It is connected to the base. And now, as it is an NPN transistor, so I will place my negative terminal of my boost converter to the emitter of the transistor, and the positive output to one of the relay coil pins over here like this. Yeah, I have placed it. And now for the ground of the relay, I will take another wire and connect it with the collector pin of the transistor, which is on the far left side, which is this one. I will connect it just over here, I've connected it. Now it is connected. Now we need to connect the step up converter with the power supply. So the negative input of the converter goes to the ground of the battery, and the positive input goes to the positive of the battery. Over here. Okay, so here the place is a bit congested, so I will place it over here. Yeah, it is connected. Now all we need to do is to connect the power supply, this and this. And now one thing I have noticed is that I have not connected any power to the LDR, so the LDR won't work. Now I am going to connect it. Now the LDR is connected. Now our overall circuit is ready. Now let's test it. I am turning on the power for the light. Now it is an AC load, so I have connected with my power plug, the wall adapter, and now I am turning off my light, and the light is glowing. So the circuit is working. Thank you.